Okay, so basically the topic that will span 3 sections would be linear functions or linear equations with two variables. So the story is, and I don't know how much of this story you want to be writing down, but if I give you one single point and I ask you to draw a line through that point, how many different lines will I get from you? How many lines can I do through that point? Yeah, infinitely many, right? But if I give you 2 points, how many lines go through those 2 points? Just one. So we need 2 points to define a unique line. Do you agree with that? But another way to think of defining a line, if I tell you that I have a line that goes through this point and is heading generally in that direction, how many lines go through that point in that direction? No, I mean in that direction precisely. Through that point, just heading in that direction. One, right? There's only one line that goes through that point and heading in that direction. So another way to define a line, all you need is a point and a direction in which the line is going to. Okay? Now there's an alternative way to describe the direction of the line, and you all know that. What is that fancy word that I'm probably thinking about? What was that? I heard it. Somebody said it. Slope. So yeah, slope kind of tells us which way the line is going. In order to define a unique line, we need 2 things. One, any point on that line. And direction of the line. And in other words, slope. So if you have a slope and a point, you get yourself a line. 95% of the time, it'll define a pretty looking line. So as you probably remember, we use a lowercase letter m to represent the slope. Now, what do you remember about a slope? What is that? What is that equal to? What? Well, yeah, that will be the equation of the line that we'll use the slope into, but just the little m. Anyone? Rise. What? Rise over run. So the slope basically describes by how much the elevation changes with respect to a horizontal shift, right? It tells us the vertical change with respect to the horizontal shift. So in other ways to call it, it's change in y over change in x. Does anybody remember a fancy symbol for change we use in math? Yeah, the Greek capital delta. So it's like this: delta y over delta x. And given 2 points, you can find the slope by taking the difference in the y, so y2 minus y1 over x2 minus x1. So for example, if I give you 2 points, you should be able to compute the slope of a line that passes through those 2 points. So find the slope. And let's say the 2 points are 1, 3, and then 3, I don't know, 9. Can you find the slope of a line that goes through those 2 points? Tell me what to do. What? 9 minus 3 over 3 minus 1. Change in y over change in x. 6 over 2, 3. Slope is 3. Right? What does that mean, that the slope is 3? How does it tell you which way the line is going? Yeah, up 3 for every 1. So you're thinking about numerator versus the denominator. So there's a 3 over 1, really. So for every 1 over, you go 3 units up. Or you go 6 up, 2 over. So any ratio of 3. Okay? So I can actually sketch this line. Let's say if I only knew 1 point on that line, let's say I only knew that the point is 1, 3, and the slope is 3, I can actually draw a line. Here is 1, 3. And the slope 3, so it means go up 3 over 1. So 1, 2, 3 over 1. So here's that line. Okay? Probably goes through the origin, actually, since it's a slope 3, but it's not that big of an issue. Is that okay? All right. If I do something like this, 0, 4, and then 2, negative 2, how about negative 3? Can we find the slope of that line? We'll do the same thing, right? We'll subtract the y values over the x values. So that's negative 7 over 2. Right? What does that mean? Negative slope. So down 7 over 2. Okay, so we always like to move in a positive x direction, and then either up or down depending on the sign. So I can sketch this line by grabbing any one of the given points. So let's say 0, 4. So I go down 7 over 2, something like that. So down 7 over 2. Is that good? Makes you feel happy, warm inside? You've done that before. I'm not breaking any new grounds here. How about this example? Horizontal, right? The y didn't change, so if I do the slope, it is 7 over 7 over negative 2 minus 3, which is 0 over negative 5, which is 0, right? Right? 0 on the top is 0. 0 on the bottom is undefined. So the slope is 0, but if you think about this line, and somebody already said that, the line is horizontal. If I plot these 2 points, 3, 7, and negative 2, 7, the line is horizontal. So the slope of a horizontal line is 0. Okay? And at the same time, if I do example like this, 3, 0, 3, 4, so no change in x, what kind of line will that be? Vertical. But right now it is 4 minus 0 over 3 minus 3, so that's 4 over 0. Well, that's undefined. So slope of a vertical line is undefined. There's no change in x. Okay, so denominator is 0. Okay? All right. Another thing I want to mention about the slope before we move forward are the parallel and perpendicular lines. What do you remember about parallel lines and their slopes? Same slope. Does that make sense why? They're both heading in the same direction. If I don't write this down, but if I have two lines and they're, well, parallel, and if I try to find their slopes, these numbers are the same. So in both cases, slope is b over a, change in y over change in x, right? So the parallel lines have the same slopes. What about perpendicular lines? The lines that form 90-degree angle when they cross. And what else? Who remembers the relationship between slopes of perpendicular lines? So reciprocals, is that it? Well, that's not that important with the intercept, but think about this. Let me just draw a line. Don't write this down. Where would the perpendicular line be to that line? I mean, which way would that be going? Yeah, so if I form a 90-degree, right? Something like this, close enough. First line has a positive slope, second line has a negative slope, right? Now, is it possible for two perpendicular lines both have positive slope, both have negative slope? All right, just because of the 90-degree flip, one is always going to point down, one is always going to point up, unless they're vertical and horizontal, so who cares about that? So, has to be opposite sides as well, right? So the slopes of perpendicular lines, in addition to be reciprocals of each other, they also have opposite sides, okay? So we call them negative reciprocals of each other. So in other words, if one slope is m1 and the other one is negative 1 over m2. So flip it, change the sign. Or every time you multiply the slopes of perpendicular lines, you get negative 1. Because first of all, you're multiplying two reciprocals, so product of reciprocals is always 1, and then the negative makes it negative 1. Is that okay? Think about this. Products of reciprocals, fractions will cancel. So let's do this quick example. I want you to find the slope of a line that is perpendicular to the line that passes through -2, 3, and 1, 7. Does the question make sense? I have a line, I'm going to call it reference line, that passes through -2, 3, and 1, 7. And my line is perpendicular to that one. So I just want to find the slope of my line. So we'll call the other line a reference line. So how do we do that? What do I need to do first? Of that reference line, right? So first, find the slope of reference line so that would be 7 minus 3 over 1 minus negative 2. So that's 4 over 3. Do you agree with that? So then what is the slope of our line? What? Negative 3 over 4. We take the reciprocal and we change the sign. So therefore, slope of our line is negative 3/4. So the lines with slopes 4/3 and negative 3/4 are perpendicular. They're going to form a 90-degree angle. Is that good? Is that a little bit refreshing, or you just know this stuff? Feeling good? All right. Okay, so let's talk about equations of lines. So first type of an equation, it's ugly. I'm going to list it here, and we're hardly ever going to use it. It's called standard form. There's nothing special about it. It's just some constant times x plus some constant times y plus another constant equals 0. So this is a standard form of equation of a line. When you're faced with a form like that, and you ask to sketch the graph, they're probably just going to find the x and y intercepts and just go, because there's, doesn't give you, you don't see the slope, you don't see anything else. But the form that you all like is called the slope-intercept form. So that's your y equals mx plus b, where m is the slope, and what is b? The y-intercept. Hence the name slope-intercept. And right, because if I ask you for any equation to find the y-intercept, you're going to set x equal to 0. That's how you do the y-intercepts for any equations. Do you hear that? Because if it crosses the y-axis, then x has to be 0 at that point. So you just plug in 0 for x, and then y equals b. That's your y-intercept. So when you see equation of a line that's in this form, then you can quickly sketch it. Because remember, you need two things. You need to have a point, you need to have a slope. So you have a point, you know where it hits the y-axis, and you know the slope, so you can go from there. Is that right? You remember that? Okay, so I'm moving rather fast through this, but I think you're doing fine, maybe. Y equals negative 1/2 x plus 1. So can I ask you to sketch the graph of this equation? How do we do that? Yeah, so you start at 1 on the y-axis, that's the y-intercept, and then you interpret the slope. What is the slope? Negative 1/2, so where do I go? Down 1 over 2. So change in y is 1, change in x is 2. So here's that line. Is that okay? Fun stuff? All right. And again, your book kind of takes its time. It goes over 3 sections talking about the same kind of concept. And so I just covered sections 2, 3, and 2, 4 with this. Section 2.5 teaches you how to find the equation of the line given some information. Okay? But by the way, from the algebra point of view, when I drew that line, I solved that equation. Remember how we agreed that graphs are solutions to equations with 2 variables? Because now every ordered pair along this line solves that equation. Every ordered pair outside that line does not solve that equation, right? That's what the graphs are. It's just kind of a convenient way to express all possible solutions to that equation, right? Okay, so finding equations. So there are 2 ways of finding equation of the line. In both cases, you still need to have a point on that line and the slope of that line. Now, most of you have done this before, the way you find equation of a line. You start with the max plus b form. You know the slope, so you know m, right? Now you know a point on the line. So what that means, you know one of the solutions to that equation, right? If a point is on the line, it solves that equation. So that means I can take this point and I can plug it in for x and y. It will still keep the equation balanced, so I can find b, right? And when I find b, I have my equation. How many of you done it that way or have no idea what I'm talking about? Which means all of you are going to have to raise your hand. So that's a waste. So how many of you understood what I just kind of briefly described? How many of you done it like that? I'm going to do an example, and I'll show you what I'm talking about. Now, there is another way of finding equation of a line using a different form that I haven't listed yet. And I'll talk about that too. But anyways, so let me just give you an example. Find equation of a line that passes through, I don't know, 1, -2, and has a slope m equals -3. So I have all necessary information for me to find the equation of that line. I have a point, I have a slope, right? So the way we can do this, here's a one way of doing this. Let's call it method 1. We will start with slope-intercept form, y equals mx plus b. Okay? So again, remember the way the notation works. M and b are the constants, so that's what we're looking for. X and y are the variables, so they will remain in our answer. Now, we know m. You know that? M is given. So right now, m was -3. So what we have now is y equals -3x plus b. This is what we have so far. We need to find that b, and we will use this point, 1, -2. Because that point is on the line, which means it solves that equation. So it means if I plug it in, the equation will stay balanced, right? So I can go ahead, put 1 for x, and put -2 for y. So that will give me -2 equals -3 times 1 plus b. Therefore, what is b? One, okay. You add 3 to both sides, so b equals 1. So therefore, the answer here, you have to tell me that the answer is y equals -3x plus 1. So we're done. So we found the unique equation of a line that satisfies those two conditions. Who's happy? You're happy? You look happy. Who's sad? Anyone sad? Who doesn't care? All right. So you will find. All right. Well, I actually don't like this way. This way it looks weird to me. I don't know why. I just don't like it. Finding the equation of a line this method. Because it looks like I'm going in circles. I have to find b. Then I have to go back and plug it in. Too much stuff to remember. So there is another way of doing this problem. So there is another form of the line called point-slope form. And I really prefer using point-slope form throughout most of these problems. Where this form coming from, I don't know if you want to write this down, but let's say we still have point and a slope. That's all we know. If I have that, I can draw a line, can I? like in that previous example, the point was 1, -2, so 1, -2. So here's that point that was given to me. The slope was -3, so I can draw a line, right? Down 3 over 1, something like that. Close enough. So now I want to find the equation of that line. But all I know that the slope is -3, right? And so in general, let's say the slope is given. We know the slope. And we know some point. At some point, let's call it x1, y1. Okay? That's what we have. We have a slope, we have a point. Now, the idea is if I take any other point on this line, this point and this point, or this point and that point, or this point and that point, if I compute the slope between any pair of points on the line, it's always going to come out to be -3, or whatever that thing was given to me. Do you agree with that? Slope remains the same regardless of which 2 points I pick on the line, right? So the way we're going to do this problem, we're going to take an arbitrary point on that line, so let's call it xy, because it could be any point, so we're not fixing it. And we know that the slope is change in y over change in x. So it is actually using those 2 points, it's y minus y1 over x minus x1. If I use the fixed point and an arbitrary point. Well, I can multiply both sides by the denominator, just multiply by x minus x1, and it will give me this expression, y minus y1 equals m times x minus x1. And this is the so-called point slope form. The reason why I like this form is if you have a point and you have a slope, all you have to do is just plug in the slope and plug in your point, and then simplify, and then the answer just falls out. You don't have to do any extra substitutions or anything like that. So let me do the same problem. So the point is 1, -2, was that right? And the slope is -3. So if I plug these values into that equation, I get y minus the y value of the point, so y minus -2, equals the slope, which is -3, times x minus the x point, which is 1. And then I'm just going to simplify this. Negative, negative gives me positive. Distribute -3 makes it -3x plus 3. Subtract 2 from both sides. Y equals -3x plus 1. Right? Same answer as before. I like it better this way. Anybody did it this way before in the past? Okay, so you usually taught both ways. I like this way better. Okay? All right. So let's do a few more problems when we're just finding equations on the line. Any questions? Everyone's happy? Kind of? All right. So find equation. Of a line that passes through 2, 3, 7, 1. So again, in order to find equation of a line, we need 2 things. We need to know point and the slope. Do we have those 2 things? Well, I don't quite have the slope, but I have all the information to find the slope, right? So the first step here would be to find the slope. And that would be 1 minus 3 over 7 minus 2 So as it appears, slope is negative 2/5. Is that okay? So then second step, I will start with point slope form. We have the slope. I have 2 points. Which one do I pick to find the equation? 2, 3 or 7, 1? Can I pick 7, 1? Yeah, I can pick either one. Doesn't matter. So pick 2, 3. So that'll be y minus 3 equals negative 2/5 x minus 2. And then we have to simplify this. So it becomes y minus 3 equals negative 2/5 x plus 4/5, right? When you distribute negative 2/5, and then add 3 to both sides, y equals negative 2/5 x plus, well, we can cheat 3 and 4/5. Any questions on that? That makes sense? You still happy? You don't look happy anymore, but sure, that would be a little awkward, but we can certainly grab this. So first of all, I need to find the y-intercept, which is 3 and 4/5, which is almost 4, but so if this is 4, then 3 and 4/5 are just right below that. And then start from that point, that nasty 3 and 4/5 point. What is negative 2/5? What does that mean? Yeah, so go down 2. So 1, 2, and then over 5. 1, 2, 3, 4, 5. So here's your second point, and I'm really just eyeballing that. Okay? On your MyMathLab, first of all, I strongly doubt you're going to have a y-intercept 3 and 4/5, because MyMathLab only goes like by halves on those graphs. So, but that same idea, you just have to, and you can always find pretty points, the ones that have whole numbers in it anyway. So, but anyway, so as far as doing this on exams or on paper, yeah, if I kind of see that you're in the proximity of the truth, you're fine. Okay. Okay. Another example. Find equation of a line that passes through a point 2, 4 and perpendicular to the line two x minus 4y plus 7 equals 0. So, in order to find the equation of a line, I need to have a point, I need to have a slope. I have a point. Do I have a slope? Not quite. Can I find that slope? Yes. What do I need to do first? What's the first thing that I have to do to find the slope of our line? Anyone? Well, if I solve for x, then I have x equals some stuff. But if I solve for y, I'll have y equals blah, blah, blah. So solving for y will put this equation into the mx plus b form, right? By the way, do I care about b when I look at that reference? I only care about m, because that will tell me the slope. So yeah. So first put the reference line into y equals mx plus b form by solving for y. And I don't care about the intercept, I just need to see the slope. So I'll add 4y to the other side, so it's 4y equals 2x plus 7, right? Just add 4y. And then just divide everything by 4. So really y equals 1/2 x plus, don't care anymore. Right? It's whatever that is, 7, 4, it doesn't matter. All I need is the slope. So the slope is 1/2. So the slope of the reference line is 1/2. Now our line is perpendicular to the reference line. So what is the slope of our line? -2, right? No. We'll find we do care now, because we actually have to find the equation of our line, but we needed to know the slope. So slope of our line is m equals -2. So it's negative reciprocal. You flip a half and you change the sign. So we found the slope. Slope is -2. We have a point, 2, 4. The rest should be pretty straightforward. We can start with our point slope form. So it's y minus the y value, which was 4, equals the slope times x minus the x value, which was 2. Is that okay? Just putting everything in. So y minus 4 equals -2x plus 4. And then finally y equals -2x plus 8. So we do care about the y-intercept here. That's the big part of finding the equation of the line. It's a very unique line. It passes through 8 on the y-axis and has a slope of -2. How's that? Happy? Good. All right. So that basically covers 95% of questions. When you have slope and a point, you can find the equation of a line. The two special cases, those are your horizontal lines and vertical lines. Those are the ones that don't quite follow x plus b format. But we already talked about them a little bit. If I look at the horizontal line, what is the slope of a horizontal line? 0. So if I go back to the x plus b form and m equals 0, what's left? B, so y equals b. So that's the equation of a horizontal line. Y always stays the same. Y is a constant. It will hit the y-axis at whatever b is, but that b will not change along any points. So equation of a horizontal line so slope equals 0, and the equation is y equals b. So in other words, an equation of a horizontal line that passes through a point AB is y equals b. So any point, whatever the y value is, that's y equals that y value. So with the same logic, when you look at the vertical lines, so slope is undefined, the equation would be, well, if it's vertical, then x does not change. X remains a constant. You could just picture a vertical line. So then the equation of vertical line, x always equals some number. So equation of vertical line that passes through a point AB is just x equals whatever the x is. So x equals A. So those are just two special cases. Example, find equation of a line that passes through 2, 7 and perpendicular to x-axis. So can you find equation of a line that's perpendicular to the x-axis and passes through the point 2, 7? What would that be? No, because if y equals 2x would be a line with slope 2 passing through the origin. X equals what? What? 2. Because first you have to picture this line. If it's perpendicular to the x-axis, it's a vertical line, right? Do you agree with that? So then you have a vertical line through point 2, 7. So the equation is x equals 2. Okay, we're a little bit off now with our smartboard, but the idea is here's 2, 7, and our line is perpendicular to the x-axis, so it's vertical. So therefore the equation x equals 2. Okay? So this is a really, really fast way to review the whole equation of line business. Now, another way to think about the slope, another interpretation of the slope, it tells us how fast y changes with respect to x. So slope is kind of a rate of change. Another way to think about the slope is rate of change. So how many of you get paid hourly? All right, whatever it is, your hourly pay rate is the slope of your weekly paycheck or whatever, right? I mean, if you think about this, your weekly paycheck, to make it a function, is whatever your hourly rate is, let's call it R, for rate per hour, times X, where X is number of hours. What? Yeah, let's not have an asymptote in that yet. But does that make sense? How many of you get kind of a flat paycheck and maybe plus? Anybody works in the commission or something like that? Huh. We had a student in another class who had a very strange setup. He gets paid $5.50 per week, period. But if he works over 55 hours per week, then he gets $10 for each hour over 55. Well, but he's mostly on call, so he might not just, the whole week he might not just do anything at all. He gets $5.50 and gets really, really busy week. But anyway, so we can come up with that scheme. If you think about this, no matter what, even if x is 0, you get $5.50. That's your y-intercept. This is what you start with. Now, on top of that, he gets $10 per each hour over 55 hours. So if we define, let x be hours worked over 55 hours, then this function will spit out the weekly paycheck depending on x, right? So if he works 10 hours, it's $5.50. If he works 54 hours, it's 550. If you work 65 hours, it's 550. But if you work 60 hours, then x equals 5, so that becomes 600. But again, this is the equation of a line starting at 550 and then the slope is 10. Doesn't get into the negative side because that won't make much sense in this scenario. But another way to interpret the slope, it's a rate of change. So you're driving 60 miles an hour times x number of hours. That's the slope of your distance. Okay, it's a change in position, kind of the velocity. I don't know, you have a heart that pumps blood at the rate of whatever per whatever, I don't know. That's a rate of change, has a slope, and so forth. Okay? Does that make sense? All right. Well, good. Well, now I'm going to make you do a whole bunch of problems. We're actually going to